Hello and welcome, my wonderful math students. What we're going to be doing is we are going to be using systems of equations to solve word problems. First up, Stefan and Cody are selling pies for a school fundraiser. Customers can buy apple pies and pumpkin pies. Stefan sold 7 apple pies and 12 pumpkin pies for a total of $169. Cody sold 8 apple pies and 13 pumpkin pies for a total of $186. What's the cost each of 1 apple pie and 1 pumpkin pie? Now, you might think to yourself, this is an absolutely ridiculous problem. Welcome to the wacky fun world of math, where we care about such things. Now, what I'm going to consider is 2 separate equations. One where I'm going to consider 7 pumpkin pies and 12 pumpkin pies. So I'm going to consider that 7x plus 12y. Just going to make myself a quick note at the top here that I'm considering x to be the price of an apple pie, and that I'm considering y to be the price of a pumpkin pie. Now, I know that when I bought 7 apple pies and 12 pumpkin pies, it did cost a total of $169. Now, similarly, I'm going to make an equation for Cody where he sold 8 apple pies, so that's going to be 8x, plus he also sold 13 pumpkin pies, so 13y, equals, and he got a grand total of $186. Now, you could use elimination or substitution to solve these, but what I'm going to be showing today with these word problems is let's just use a graphing calculator to get them done a whole lot quicker. So I've already got my Desmos calculator pulled up right here, as you should probably, and I'm going to go ahead and type these 2 equations in there and get a final answer. So I'm just going to simply type in 7x plus 12y equals 169. And in the other one, I'm going to type in the 8x plus 13y equals 186. Now, the beautiful thing about the graphing calculator that we use is that it's pretty easy to use. So I'm going to zoom out and I'm going to click on the equations. Now, it's going to try to show you 2 different points. You're going to actually want the one that's the intersection of the 2 lines, as I've selected. So 710 is our answer, but let's actually interpret this result now. So back over here, what I'm going to actually say is that apple pies are $7 each. Pumpkin pies, however, are $10 each. A lot of the problems that you'll see are kind of like that one, where it lines up very easy. It would have been easy to do with elimination, but we went ahead and knocked it out with the graphing calculator pretty well. While most of the problems on this assignment, it's going to be like that first one we looked at. Some of them are going to kind of be like this. This one's less popular, but it is out there. So a plane traveled 1,683 miles to Kinshasa and back. The trip there was with wind. It took 11 hours. The trip back was into the wind, so it took 17 hours. So you're obviously going slower because you're fighting the wind. What is the speed of the plane in still air? So I'm going to make that my x. So x is speed of the plane in still air. And I'm going to make my y the speed of the wind that it's also asking for. Now what I'm going to do is set these equations up. Before I do that, however, I am going to figure out the speed getting there and the speed getting back. So I'm going to make a quick note. Speed with wind is the 1,683 miles divided by the 11 hours that it took with the wind. So I'm going to quickly calculate that. Just going to use a calculator is all I'm going to do. I'm going to X out what I had before from the first problem. 1,683 divided by 11. Get 153 miles per hour. And now I'm also going to calculate the speed into the wind. So that's still using the 1,683. But now the time became 17 hours. So I'm going to delete the 11 and put a 17 in its place, and that's 99 miles per hour. Now, I know that some of y'all are pretty clever and you wouldn't actually need the system of equations I'm about to use to get this problem right, and that's fine. I'm just going to show how the book's expecting you to probably do it. So here we go. I'm going to go there. So I'm with the wind, so the speed of the plane gets boosted by the speed of the wind. You simply add the speed of the wind to the speed of the plane in still air. And that equaled 153 miles per hour. Now, let's make an equation for coming back. So since you're going into the wind, the speed of the plane in still air has the speed of the wind subtracted away from it, and that resulted in it going 99 miles per hour. At this time, you could use elimination or graph it. I'm just going to stay consistent on this lesson and just graph, but know that elimination would be really, really easy here. And let's go ahead and see what we get for answers. All right, so typing in the first one now. I'm going to slide that over. There we go. So I'm going to type in the x plus y equals 153. And I'm going to type in the x minus y equals 99. Now, I do have to zoom out on my screen here until I see the intersection of the two lines, which gave me 126.27. All I got left to do is interpret the results. So, the speed of the plane in still air is 126 miles per hour. And for the wind, that's my y value. As I made note of earlier, that's the 27 miles per hour. And I'm finished with this problem. All right, please email me if you got any questions, guys. Thank you all very much, and good luck with getting your assignment done.